I'm Trevaughn Strauther.
And I'm Lejay Smith, and our video will be about free fall.
A free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. There are two important motion characteristics that are true of free-falling objects,
Which are free falling objects do not encounter air resistance, and all free falling objects on Earth accelerate downward at a rate of 9.8 meters per second squared. Now we're going to do an example problem for free fall. We're going to calculate a one-dimensional object from free falling by finding the velocity. So I'm going to draw a picture that we'll be using. This is a cliff, and I'm going to draw a stick figure person, and the person is going to be holding a ball that they're going to be dropping downward. And the height of this cliff is going to be 30 meters. And we're going to try to find the final velocity of the person, the stick figure person dropping the ball down. And that's going to be our picture. So we're trying to find the final velocity of the object, and we're going to need to use our three kinematic equations. So we're going to use our kinematic equations. And three of the equations are V final equals to V initial plus gravity times time. Then another one is this one. 2G Y. And then another one is So we have to look at the two equations to figure out. Okay, I made an error on this one. We have to look at the two equations to figure out what will we need to, what equation will we use. So since we already know that we're not looking for time, which is time is used in this one and time is used in that one, we won't be using either one of those. So we'll be using the second one. We're trying to find V final. So V final squared and V initial squared plus 2 times gravity, and this is the height. We know the height is 30 meters, which is right here. And we don't have an initial, so the initial will be 0. So we won't even really use that one. And G is 9.8 meters squared. It is negative because we're doing it in the Y direction. The object is being thrown down. So since we're not using the initial one, it will be V final squared. Well, it wouldn't be squared because now we're just going to do a square root of everything. So it'll be 2 gravity Y direction. So we have to find our Y direction in initial and final. So it will turn out to be 2 times negative 9.8 meters squared. And we're going to multiply it by the Y direction, and it will be 0 for the initial and you're subtracted by 30 meters. So basically these two negatives are going to cancel out because we can't calculate negatives in a square root. So then we're just going to put this in the calculator. Square root. And the answer came out to be 24.248. And we're just going to round that to 24.25, and it's going to be meters squared. The key is with free falling, their answer can be plus or minus. But since we're going to be doing free fall going downward in the y direction, we want our answer to be a negative. And that's how you find free fall.
Free fall with the Jason.
Our conclusion is that when dropping an object from a 30-foot cliff, the velocity of the object will come out to be plus or minus negative 24.25 meters per second, and it will be at negative 24.25 meters per second because you're dropping the object at a downward position.
My name is LeJ Smith.
And I'm Trevaughn Strauther, and thank you for watching our free fall presentation.